Okay, in this presentation we're going to have a quick look at how to work with the Murdoch-Barnes probability tables, the statistical tables, when we're dealing with the Poisson distribution. So the Murdoch-Barnes tables is commonly used in undergraduate statistics, and you will probably have it in your exam when you do your exam. Okay. Now what we're going to do is we have to go to tables 2 for this particular set of tables. So you just sort of flick through it and you should find set 2, the cumulative Poisson probabilities. And this tabulates the cumulative values for the Poisson probabilities. Now this is important, this bit. So for some value r, suppose we're asked in the question, find the probability of x greater than equal to 5, something like that. In this case, r is 5. That's what we're looking for. So that will be along the column. Okay? Those values along the column. And they should go from 0 to some sensible upper threshold. Okay? Now these tables give the probability of r or more occurrences for a random variable x. Okay? So the probability of x greater than or equal to r. Okay, that's very important actually for some value m. M here is the expected number of occurrences per unit period. Now that's how we sort of define the Poisson distribution, the expected number of occurrences per unit period. Okay. Now just as a quick remark, in the tables they are called M. Okay. But you will probably know them as lambda. Okay. So I suppose just for the sake of simplicity, the Poisson mean in the tables is known as M, but quite often it will be written in other texts as lambda. Just watch out for that. That's the thing about statistical notation. It's hard to keep it consistent. Now, so to use the tables, the correct column of M must be found. So this could vary from question to question, depending on what the unit period is. So if it's 0.5 for 1 hour, let's say you're told that, and you're asked about 4 hours, then you have to adjust accordingly to use m equal to 2, which is 4 times 0.5. So just watch out for that. It could sort of change from part of the question to another part of the question. The cumulative Poisson distribution is easy to use compared to the cumulative binomial tables. So this is assuming that you're also, if you're probably going to be using the Poisson tables, the likelihood is that you will be encountering the cumulative binomial tables, which is very similar, but just a sort of quick remark upon that. If not, don't worry about it, but it's sort of strange if you're looking at this, the Poisson tables, and not the binomial tables. So all of the problem solving approaches we learned for the cumulative binomial tables also apply for the cumulative Poisson tables. Okay, that's grand. Now that is essentially the idea of a sample space. So the probability of x equal to k is the probability of x greater than or equal to k minus the probability of x greater than or equal to k plus 1. So that's the approaches I'm talking about there. Okay, that sort of way to use the tables if you want to get a specific value. Something you might also be asked is probability of x less than or equal to k. Well, that would be 1 minus the probability of x greater than equal to k plus 1. Remember, we are dealing with a discrete probability distribution. Okay, so this is the complement of that. Okay, now so that's what I mean by the all the problem solving approaches we learned for the cumulative binomial tables. These sort of approaches down here. So this is what the table would look like. We have r aligned on the columns there. So there's a row for each of these values of r, and along the top we have m. So we could have a column for 0.5 and a column for 0.4 and a column from 0.5 and so on. Okay, so essentially what you have to do is pick out the right, let's just say in this case it's m equals 0.5. Just pick out the right column and work from that only. Okay. So if this is not going to be used, you can disregard it. Okay. So suppose that for a Poisson random variable that the mean number of occurrences is 0.5. Calculate the probability that there be more than one occurrence in a minute, given a minute. So more than one, actually one or more, I should say. No, I'll tell you what. Yeah, I'll just actually go with this. One or more, probably x greater than or equal to 1. So this is one or more. That is 0.93935. Okay, so that was the row, and that's the column. Okay. Now, sorry, just to be clear, actually, there's a bit of ambiguity with regard to the question I asked. So it's actually here, it says more than one occurrence. That is the probability of x greater than or equal to 2. So it's a little bit of a mistake here. The probability of x greater than or equal to 2 is more than 1. Okay, so let's go again. And what we do is we go to this column here, or this row here. And in that case, the answer is 0.0902. Okay, that's it. That's how you do it. I'll tell you what, just one more. No more than one. Okay. No more than one. So just add a third variation. Okay. That's the probability of x less than or equal to 1. And we will use the complement of that to solve the question. That is the complement of the probability of x greater than or equal to 2, which we know, and that is 1 minus 0.0902, and that is 0.919098. Okay, so that's 3 questions for the price of 1. So just as a sort of quick recap, I made a slight mistake here earlier on. Probability of x greater than or equal to 1 is not more than 1. That is probability of x greater than or equal to 2. Okay, so that's how we go about it. Okay, we'll leave it there.